right, everybody. Thanks for coming. I know it's really nice out there, and it's pretty tempting to just hang out outside, so thanks for coming to the meetup. As you know, it's Eugene Web Devs. We do this every last Thursday of the month. We're continuing to do them every last Thursday of the month. At this point, we don't have a speaker for next month, so if anyone's interested, hit me up here after the meetup, and we can talk about possible topics. So, first off, thanks IDX for the space. Everybody likes space. Couches are nice. Yay for this place. Also, we have a sponsor, Accelerate. They do training, professional training for businesses. So if your business is interested in this, the link is here. The link will be available. It's available right now on eugenewebdevs.com as well. So for more information about them, check them out. Thank you, Accelerate, for the sponsorship. Also, everybody's enjoying pizza from Pizza My Cart. It's a food truck just down the street. Yep, applause for Pizza My Cart. Food truck just down the street. They're open later now, and they're right there on Broadway, so just 2-3 blocks west from here. Visit them. They're great. I like their pizza, so we'll be having them probably for the foreseeable future. So, with the sponsorship out of the way, I'm just going to turn it over. Here we go. Let's all welcome.
Thank you. I am Michael, and we're going to do this little cloud talk today called IaaS, PaaS, or SaaS. No one writes for free. So those of you who know get the joke, but we're being recorded, so I won't explain it. So who am I? I do cloud architecture. So right now I work for a company called Commvault. We do data protection, and I am on the alliances team. And what I am responsible for is working with AWS, Azure, and Google Cloud Platform to integrate and make sure our stuff works and that the customers are happy, and then everything kind of is cool, copacetic. I also do a lot of networking stuff. So I call myself a full stack person, not a full stack developer. So I do all 8 layers of the OSI model. So the 8th layer is the money and the politics, because I've done lots of consulting and stuff, so that's where I am. I also have worked in infrastructure, so I am old enough back in the days before there was a cloud, and you actually had to order computers and servers and air conditioners and run cable and disks and get paged. I had a Motorola two-way pager, all that kind of fun stuff. So I've done all that. And I have a lot of experience in disaster recovery. So for some strange reason, I'm one of the weird people that likes to do backups. Most people don't like to do backups, but I do backups. I've been a backup architect for Amgen. I used to work at NetApp doing disaster recovery stuff. So I like to think about what's going to go wrong and how to work around it. So I call myself a Murphyist. So I strongly believe in Murphy's Law. And I'm not a programmer, but I play one on TV. So I like to say that. So I typically have a hard time writing arbitrary code. Typically, it's to support some activity I'm doing. So whether it's backing stuff up, I write a lot of programs that back things up or recover or kind of infrastructure things, or just doing some kind of project I want to do. And as I said, I'm old. I've been working in IT for too long, almost 30 years doing this. I should probably do something else, but I've been banging on the keyboard so long, I'm not really sure what else to do, so here we are. So if you want to find me, I'm at BarrowMe on Twitter, and I'm Michael at BarrowMe and that old email stuff. Okay, so the first thing I want to get across, the most important thing in the cloud talk, is that there is no cloud. Right? So this is very important to remember. There are lots of wispy and ephemeral words that are used in the cloud space, but when you're architecting and designing things, you have to remember that there are real, actual physical resources and people and constraints back there. And so this is very important to remember. So what do we mean by that? There's no cloud because there's just other people's computers. And that means that you are subject to whatever design parameters they use when they're putting those systems together, whatever hardware vendors they use, whatever service level agreements they extend to you or don't, as the case may be. And when you build a platform or an application that's on the cloud, you are inviting all of these people onto your team. They are part of your team, and all the decisions or mistakes that they make, they're part of your stack as well. So that's always important to keep in mind. So if we have all this danger and all these weird people that I don't even know and all their weird design constraints, why would I want to use the cloud? Well, there's lots of reasons to do it. The first and foremost, especially, probably most of you are developers, you're not old and crufty like me, where you had to build your servers uphill both ways in the snow. So what you want to do is just write your app and not worry about the operating system, not worry about whether or not the server's on, whether or not there's power, air conditioning. I'm just trying to think of all the horrible things that have happened over my career. Whether or not there's a glycol leak in the data center upstairs that spills down and shuts down everything on the first floor. You don't have to worry about all that. You can just go to some web page or to some REST endpoint, provision up some resources, write your code, boom, you're ready to go. For traditional enterprises, they are trying to figure out how to shut down data centers, right? So they have lots of computers, they have all those old legacy things, and they want to move them someplace else because they want to take advantage of this utility computing model. So in the old days, when I worked in large enterprises, somebody would say, hey, I want to put a new application online. And I'd ask them, well, what do you need? And they would tell me some metric, some number, and I would take that and I would double it. And then I would go to the next person in the chain and tell them my number, and they would take that and they would double it, right? So in the end, you have this giant, massive thing, and obviously that costs a lot of money. You have to pay for it, you got to order it, you got to install it. The cloud gets rid of all of that. You can order up whatever resources you need. They're instantly provisioned, more or less instantly provisioned, and then you can grow them. So that's the elasticity you hear in the cloud. So we would always have to design for the maximum usage. With the cloud, you don't have to worry about that. You grow it when you need it, and most importantly, you can shrink it when you don't need it. So that's kind of one of the reasons why people use the cloud. So you just don't want to deal with the frustration, the pain and the agony, and you want to be able to have that elasticity and utility computing. One of the fallacies, in my opinion, is that automatically moving to the cloud, and I don't know how many of you are working in legacy environments. I work with a lot of folks that are taking things and moving them to the cloud. So there's this, I call a fallacy, that automatically moving to the cloud saves money. Now, it probably does in some capacity because it's very expensive to build and run data centers and have people and have security guards and all that kind of fun stuff. But I think the real thing that you save money on when you move from a legacy kind of data center architecture to the cloud is the fact, like when you move houses. When I've moved, I don't take everything in my house, jam it in the truck, and then spill it out in the new house. You go through all of your things, and you're like, hey, these 5 boxes have been closed for the past 8 years that I've been living at this new house. Maybe I shouldn't move them again, right? So when you see people actually go through a cloud migration, they start to inventory everything that they have. And I think it's that causes the biggest cost savings because they get rid of all this cruft. I find it hard to believe that a lot of organizations, from a security standpoint or a management standpoint, have thousands of servers and applications that they just don't even know about, but it happens. So going through all of that, understanding how these things are architected, figuring out, hey, we have these 10 servers to run this application that one guy uses once a year, maybe we don't need that anymore. We can put that on a tiny virtual machine and sling that into the cloud, or just put it underneath his desk, whatever it is, right? So that's the process that I think helps save the money. All right. So one of the things that's important to understand is all the different types of clouds. So I say that there's 4 types of clouds. You have a private cloud, you have infrastructure as a service, platform as a service, and software as a service. And what I've done to help explain that, and I didn't even know we were going to have pizza tonight, but is I use the pizza. A couple of months ago, we had this discussion, cloud versus pizza, right? So when you have a private cloud, what you're doing is you're taking the raw ingredients. You're taking the flour and the big block of cheese and the tomatoes. You're taking all that stuff. And you have a recipe, which is basically a software stack. So something like OpenStack, or this guy from AWS here or Amazon here, Azure Stack. It's a set of resources, a software stack that helps you use your hardware resources that you have on premises in a very utility-like model. So again, when we go in the public cloud, we go to a web page, put in our credit card number, or log in, create some resources, boom, they're there. We don't want them anymore, we throw them away, right? So whether it's a web page or REST endpoint via some API, we can provision those resources and deprovision them just as easily. A private cloud gives you that software stack so you can do the same thing with your own gear. But you've got to go, if we go back to the pizza analogy, you've got to go find all those, you got to go to the store, you got to figure out how to mix all this stuff together, and you're responsible for every piece of it, okay? Moving up, we have infrastructure as a service. This is where we do our transition to public clouds. Infrastructure as a service, I call it, well, kind of a, what? Okay, sorry. Make a meal in a box. So if you think of those, I don't want to use any vendor names, you order, it comes a box with food inside, and it's all pre-measured and is a recipe, and you just follow the instructions. That's kind of the equivalent. So if we had a pizza like that, we have all the ingredients, we can mix them together. Some of the stuff is taken care of for us. We didn't have to go shop for anything. We didn't have to figure out what the components are, how much of them we need. They're all set up together, and we can do that. But we are responsible, again, for combining all of them, following the recipe, following all the instructions, and we could still burn the pizza in the end, right? We're still responsible. Platform as a service is kind of like a take and bake pizza. So what we do is we just kind of go to the store, and it's a pizza, it's already made, it's got a lot of we tell them what we want, and we just have to take it home and stick it in the oven. We can still burn the pizza, but a lot more of the decisions have been taken away from us. We don't have to worry about all that stuff. We say we want a pepperoni pizza, it's pepperoni, we take it home, put it in the oven. As long as we do it right, we get a pizza in the end. And then finally, the last one, software as a service, it's like pizza delivery. We decide we want a pizza, pizza comes, we eat the pizza. We don't have to do any work except lift it up and put it in our mouths, right? So with software as a service, that is what you get. You are really focused on kind of your business problem as opposed to any kind of coding and no infrastructure. All of that is kind of hidden from you when you get up there. You'll also see random letter as a service, AAS. I personally think of that as marketing babble, right? I think pretty much all the other kind of things like storage as a service, backup as a service, functions as a service, beer as a service, whatever it is, right? You can fit them into one of those other categories. So if you ever see that, just ignore it and know that it's one of the other 3 categories. And then another thing that is pretty popular with enterprises is this thing called hybrid cloud. I don't know why they call it that, but enterprises that are either transitioning into public clouds or deciding that, hey, we're just going to put some applications in the cloud, but we're going to keep the rest of the stuff on premises. That's a hybrid cloud. So you'll have a connection between the public cloud and your legacy data center, or maybe they'll have 10 data centers and collapse that down to 2 of them, and they'll keep running their legacy apps and then just connect to the public cloud for other resources. So it's a great opportunity to do things like dev and test. So maybe they want to run production on premises because they get the warm and fuzzies from having people like to have their computers next to them. Sometimes it's like, oh, I can see it. It's got blinking lights. It's working. So they run that in production on premises, but then they will kind of get rid of all the servers that they had around for dev and test and other kind of reporting, and they'll just jam all that stuff in the cloud because they can spin it up and spin it down. Make sense? You could, that's called a multi-cloud. So the question was, if you're using Amazon for some things and Azure for something else. So that's a multi-cloud thing. I didn't have a slide for that, but I'll talk about that now. The NIST, they recommend having a multi-cloud strategy. We'll talk about that a little bit later. But in reality, it's kind of hard to do that, like full-bore multi-cloud strategy. It's really hard, and we can get into that later. But there are people that do that. At a minimum, what you can do is you can maybe have one cloud as your primary cloud where most of your applications are running, and then do what people call a data bunker or a coop in another cloud. So you have a copy of all your data jammed in the other cloud. In the case of emergency, you can break glass, and you have all your data, and it's not just held hostage in that first cloud. Any other questions, comments? Always yell out if you have something, or if I say something stupid, please call me on it. I'm not a Eugenian originally. I'm a New Yorker, so I will not be offended if you yell things, even obscenities at me. So, all right. So, how to pick your cloud. So, like we talked about, with infrastructure as a service, you have maximum control, but you also have maximum responsibility, right? So you can go in and say, hey, I want this many processors, this much storage, this much RAM, but for the most part, you have to figure out what OS to put on the machine, which patch level, what software you want to run on the box. You have to do all of that. So what you get rid of is you get rid of all the pains of having to maintain hardware. So when a hard drive crashes or SSD, it's written out all of its life and it turns to a read-only piece of metal and plastic, you don't have to worry about that. You're sleeping in your bed, some other person gets paged or they're already at work sitting in a cold data center 3 levels below the earth, and they have to deal with all that. So that's the advantage with infrastructure as a service. And again, all that lead time that you used to have in the olden days, back in the 1860s, when I first started doing this, you don't have to order a server and wait, and they go, oh, there was a flood in Thailand, and we have no hard drives. Like, you don't have to worry about that, because it's just a magic button that you click on the console, and you have disk. Platform as a service, you get a moderate amount of control, and then what you're left with is you can get to focus on coding for your business problem. So things like Lambda, AWS Lambda, for example, there you don't have to worry, or the serverless, it's one of those, there's no servers, it's magic, right? So you just write code that has to do with your business problem. You don't have to worry about, well, which web server should I run, Nginx, or I want to run Tom, like you don't have to worry about any of that. You can really hone in on the code for your business problem and get going. But the provider has made a bunch of decisions for you. That's kind of the yin and yang of it, right? Going on to software as a service, you have minimal or no control, right? So I'm sure lots of people use G Suite. You can change the colors. You can set labels on your email. You can create your folders and stuff and rules, but you can't decide, I don't like the way this IMAP server works in Gmail, I'm going to change it. No, it's not an option. Or if you're using Salesforce.com, that's the stack, right? You can't make a lot of changes. Same thing for Dropbox. Whatever the rules are, those are the rules. You can get in there and do your stuff, and you're really focused on a business processes at that point, right? So I'm reading email, I'm creating slides for the Eugene Web Dev meetup, and that's it. You're not coding. There's a little bit of customization sometimes, depending, but for the most part, they take away all your decisions. And basically, it is, I call it pain avoidance versus stickiness, right? So for you, the customer, the user, you're trying to avoid a set of pain, right? Somebody who is a pure developer, the thought of trying to patch a server is horrifying. They don't care, right? So they're willing to give away that responsibility to some poor bastard that will do that, okay? However, the further down on these things you go, you become, and this switches around to the service provider, it becomes a stickier solution. So anyone that's done software as a service things, or any kind of vendor, you want to make a solution that's sticky, right? So some people make the thing so awesome that people just won't want to leave. Other people make it so that you could leave, but it's going to cost you a lot of money and a lot of time, right? They want to get that bar really high. And you're like, yeah, it's $9,000 a second, but I'll have to patch a server. I don't want to deal with that, right? So I'll just keep paying the bill. So, I mean, that's basically the trade-off there. Question?
I'm having trouble differentiating in my head what the difference is. So, like, infrastructure as a service would be, to me, right, AWS, Azure, Google Cloud Platform, those are all infrastructure as a service. If you're, like, selling those products, you're like a reseller, right? You're making a percentage off of whatever. Platform as a service is the one I'm having trouble understanding. Like, I know software as a service, there's, like, a specific business need, and your company writes software that meets that need, that relies on this infrastructure, right? But, like, I don't know, I guess I'm just missing the platform as a service.
Okay, so all the AWS, Azure, Google, whatever, they're more than infrastructure as a service. So they have probably a mix of all three. They have lots of options. Infrastructure as a service, I think the way it is I would think about it is, hey, I need a server to do X. I don't have one here, right, in my house or in my office. I need to get a server right now with X amount of RAM, Y amount of disk. I would use infrastructure as a service to get that. So I can go to a web page or a REST endpoint and provision a server, an empty metal or virtual metal, and then I could load whatever software stack I wanted to. I can put, Slackware 1.0 on there from 1980 or 90, whatever. I can put Oracle version 5. I can do whatever I want. I have to maintain that box. The problems I've gotten rid of is having to buy a box, having to cool it, power it. That's all taken away. And when I want to buy more disk, we'll say that again.
So like AWS or Azure or Google Cloud Platform would be more of like a hardware service.
All three of those, they have all of these options.
Yeah, EC2 would be
So EC2, Elastic Block Storage, that's infrastructure as a service. You're just getting virtual hardware for some needs. Platform as a service, you would see things like I said, AWS Lambda, or like serverless, or Heroku, where you write stacks, you load your code in there, and just magic happens. You don't know what the OS is. You don't. You just pick your programming language, jam it in there. AWS Beanstalk, Google App Engine, those types of things. It's a platform. They've made a lot of decisions for you. They've picked the OS. They picked the OS version. They pick what patches are on there. They give you a set of software, and as long as whatever decisions they've made are compatible with what you want to write or solve for, you're golden, right? You might even consider S3, for example, or Google Cloud Storage, or Azure Blob Storage, as platforms as a service, right? They're not traditional disks. You don't have to format it. You just jam things in it and pull them back out. You can host a website, a static website on it, right? And then software as a service, that, like you said, that's easy. That's your Gmail, or Salesforce.com, whatever. I can't. Right. So the IaaS, you have to do more work, right? So you have a server, OS has to get on it, software has to get on it, and then finally you can start writing your app. Platform as a service, you can start writing your app. It's written on top of an opinionated stack. They've made decisions for you. There's certain rules, certain things you can or cannot do. As long as you can abide by those rules, you can write your app. But with platform as a service, if you decide, hey, I wrote my app for Heroku and now I want to go and move it to Lambda, that is going to require some work because it's a completely different thing. They're not compatible with each other, but that's what I'm saying. You're kind of stuck on Heroku, let's just say, for example, not to pick on any provider. We love everyone. You're stuck on that stack until you can figure out, learn Lambda, and learn all those different set of rules to move your stuff over, right? So whereas with infrastructure as a service, it's, on AWS, it's called, an X1 Tiny 4, extra large or whatever, and then on Google it's called something different, but you can pretty much go CPU to CPU, RAM to RAM, and then pick up your stuff and just copy it over and get going. So it's not as sticky. The other thing that you get with infrastructure as a service is all the other stuff, in addition to the server kind of maintenance for you, things like firewalls, all the basic kind of dumb things you need to do for security, they kind of cover your back on that. And they make it really easy for you to add additional security and services with infrastructure. Make sense?
Yeah. Are you, so like for the infrastructure as a service, as a business provider, responsible for hosting data with the infrastructure as a service because these companies provide security for you? Does that mean it's like not a liability to you? Or are you still liable for a data breach?
You're always responsible. So I'll talk about that later. You're always responsible for your data and your stack. There are certain things you have to actually make sure to ask them questions. So you have to go through the whole list of things. Like AWS, for example, they have this thing called the well-architected framework, where they've already done a whole bunch of work, and you can go through there and they say, hey, AWS does all of this stuff, right? And they also have this thing called the shared responsibility model, where it says, hey, you don't have to worry about building a data center with diverse power supplies. You don't have to worry about air conditioner. You don't have to worry about what kind of servers they are, right? They take care of all that, but as far as your kind of responsibility, you still have to make sure that they've done that and do your kind of due diligence. All the big providers have done that. If I open up a cloud provider next week, maybe I'll cut some corners, but it's your responsibility to ask me what my procedures are. And all those guys, they go through auditing and all that kind of stuff, and they have everything documented, so you can incorporate all the work that they've done into your documentation to cover your liabilities with your downstream customers or insurance company or whatever it is. All right, any other questions? Let's keep rolling. All right, so designing for the cloud. I see lots of people, again, you guys are all developers, so maybe you know some of this, but when I work with enterprises, they don't really understand. And I've worked with some other developers that are used to working in a legacy environment where you walk down the hall, you can look through the glass window and see the server, and if the code is a little bit inefficient, big deal. Well, that's not the same thing on the cloud. Everything has a meter on it. Everything. I wish I could make a visual of walking through life and seeing meters on everything. That's what the cloud is like. In fact, I think it was reInvent before last, AWS reInvent. They actually did a talk on how they measure all the things, right? It's a massive back end that's just spewing data for all the different things. It's like, oh, someone took a footstep. Count that. Oh, you drank 3 ounces of water. I'm going to count that, right? So everything has a meter on it. And when you're on the cloud, when you're developing for the cloud, you have to keep that in mind. You can't just say, hey, you know what? I'm going to provision, I'm going to do that. I'm going to get that EC2 instance that has a terabyte of RAM. I'm just going to fire it up. It's got a bunch of NVMe drives on it, and I'm just going to leave it running all month, right? If you're not using that compute power, doesn't matter. You reserved it. They're going to bill you for it, right? So the cool part about it is that there's lots of different options, and you can grow and shrink, right? Either vertically or horizontally. I need 50 machines. I need 5 during the quiet times. And I can even spin them down. I only need 1 CPU and a little bit of RAM. And then, a thundering herd comes. You can grow it out. But you don't want to bring those legacy techniques of I'll just fire it up and leave it there, right? You hear lots of horror stories of people that are over provisioning, and the end of the month comes, bow, 10 grand, right? So, I was doing some stuff. I'm pretty conservative in what I do, but I did forget I had a larger instance running. Boom! Oh, I forgot about that, right? And it's all the disks. Everything's got a price tag on it and a meter. So you got to remember that. Hey, man, it's just like any drug dealer, man. The first one is free. Right? So, it's not just, I don't think it's deceptive that they do that. For people that are not used to the cloud, they've got to give some level of comfort to get people to experiment. And I think all of the providers, when you try to use resources that will push you out of the free zone, they'll give you a warning. So like with AWS, you go to try to fire up some big thing and be like, hey, I just want to let you know, this is not in the free tier. Right? So they do tell you. And then also they have a lot of circuit breakers that are installed in a default account where you are limited in the amount of resources that you provision. I think in the early days it probably wasn't like that. So people would go in and they'd write some code. It was like, oh wow, I can just call this API and like create a server out of thin air. So they put it in some loop, and it's an endless loop. And they fire up 1,000 machines, right? So the circuit breakers will stop you if you have a new account. Plus, there's also, hackers and crackers and spammers trying to fire up machines, right? So it'll block all of that, and then you actually have to talk to a human or open a ticket if you really need more than that. And then, I know in AWS for a fact, the really big metal, if you just sign up for a basic account, you cannot order the big metal. Right, the $32 an hour machines, you can't get that with your basic account because they want to have a conversation with you. Do you know what you're doing, right? So it's not so bad. You just have to keep that in mind. The cool part is that you have this kind of smorgasbord of things to pick from, and if you don't need that, heavy gear, you can go tiny for lots of different workloads. And you can kind of custom fit for what you need. Infrastructure is shared. There's another problem I run into with traditional developers. They are used to having kind of a machine or set of resources to themselves. And the cloud platforms are a shared resource. Yes, there's a lot of stuff going on, magic, software-defined, networking, software-defined, whatever. There's a lot of stuff going on, but fundamentally you are sharing resources with other entities, unless you pay extra and you ask for dedicated resources, of course. But you have to keep that in mind. So what you'll see sometimes is there might be some variability in your performance in certain circumstances because, hey, everybody else decided to launch 1,000 machines at the same time, so you got to wait a little bit or something like that. Or traditional things like I work a lot with storage, taking a snapshot. People are used to taking a snapshot on like a NAP array or even with Linux LVM. Take a snapshot, it returns right away. Take a snapshot on the cloud, little wheel might be spinning for a while, right? So you just got to get used to that. It's a shared resource. There's some variability there, and things don't work like they used to in the data center necessarily. Read the fine print. There are either minimal service level agreements, or they're not what you think they are. And the one that I see people get tripped up with all the time is like for S3. So they see 99, they see 11 nines, right? And they're like, it's 11 nines, bro. I don't gotta do nothing, it's cool. That's 11 nines of durability. Durability is not the same as availability. I have seen this mistake over and over again. Durability means it will very much likely be there when you want to get it. But you may not be able to get it, right? That's availability. Is it going to be there when you need to get it? It's down, we crashed, or whatever. When we come back up, your stuff's going to be there. That's a durability. So you got to read the fine print. And again, this is a thing that people are used to in the data center. Something's wrong. They go over like 5 cubes. They punch some guy in the back of the head. Get my server back online. You can't do that on the cloud. You don't even know where it is, right? Stuff is going to break on the cloud. You have to design for things breaking. So if you've ever looked at any of the stuff that Netflix does, they open source a lot of things. My favorite Netflix thing is Chaos Monkey, right? What does it do? It's like you let a monkey loose in the data center and it's breaking stuff, right? So it will break things, and if you've written your code properly, it won't matter because you're designing for things breaking. But it's really important. Again, shared infrastructure. It might be really busy when you make a request. Back off, ask again, right? So if you take the AWS Dev certification, I can't say officially, but there might be a lot of questions about what you do when things aren't available, right? So it's very important. It's a very important design parameter to assume that things are going to break. And the last one is that all clouds are not the same. You will see, like any good marketing, the words sound the same between the different cloud providers, but they're not the same. So you have to ask questions before you go and turn over your stack. Remember, you've invited these folks into your stack. They're part of your team now. Just because they make certain claims, it doesn't mean that those claims are true. So you have to go ahead and do that due diligence. Pull up all those papers, all the audit reports. You got to go read through all of that before you bet your farm on a particular cloud provider. Any questions? Comments? Complaints? All right. Cloud comparisons. So this is, we touched on this earlier. The headers on top are generalizations. This is not, I don't mean it to reflect negatively on any provider. The stuff on the left, those are the bigger clouds. You have lots of flexibility, but there's more complexity. So earlier when you asked, oh, those guys are infrastructure as a service. Nope, they're infrastructure as a service, and platform as a service, and software as a service, depending on which of the 150 things you pick off the menu, right? So if you get an account on any of these things, whether it's AWS or Azure or whatever, you'll click that thing, and then it'll be like a multi-level menu. You want storage? Oh yeah, I want storage. Oh, what kind of storage do you want? What tier, right? So there's all sorts of different options, and you can kind of build anything. It's like a giant, it's a box of 100,000 Legos. You can build whatever you want, but you have 100,000 Legos that you're going to step on in the middle of the night and hurt your foot, right? So anybody with kids will know what I'm talking about. So AWS is kind of the grandpa of this. They've been doing it the longest. They have probably the most cohesive, kind of holistic set of offerings. And if you follow their announcements, it seems like every day, hey, we have this new service. We have another new service. We have another new service. And the other ones are similar. And then they're good for different things, I'd say. AWS is, again, they've been around the longest. They have a lot of different options, a lot of different service options, and they are a pretty good overall public cloud provider. Google, I know, is probably the smallest of the three as far as the number of customers they have connected, but they're focusing on, they have a focus on open source. They do a lot of open source stuff, like Kubernetes and all that kind of fun stuff. They use KVM for all their back end, and they are focused on doing a lot of AI and machine learning, right? So they built chips to do machine learning, and they encrypt everything, and they're pushing more into an enterprise focus. AWS has a lot of companies that have flipped over their entire, shut down data centers and moved into AWS, and Google is starting to do more of that. Azure, heavy Microsoft, but they also do Linux, of course. But you'll see a lot of traditional enterprises that have agreements with Microsoft. So, enterprise agreements, they will flow into Microsoft, and then, they have Azure Stack that was recently announced. That is to help those enterprises that are maybe not really comfortable going onto the cloud just yet. They have a private cloud stack that people can build, run in their data center, but it uses the same kind of APIs and interfaces, so they can get comfortable with that and then spin those workloads up into what I call big boy Azure, right? So those are the different options there. Yeah?
I do have a question. So, several years ago, when Google Cloud Platform first came out, it was this, I might be 100% totally wrong, right?
Or you could be right.
AWS wasn't a thing at that time, right? When Google Cloud Platform was released and announced, and my understanding was that AWS initially ran on.
AWS has been a thing forever, right? So AWS has been around almost forever. Not forever in 30 years, but they've been around probably. I think they're the oldest cloud. They're the biggest. They have the largest market share. They have most customers.
Now, but I remember when Google Cloud Platform got released, because I got invited to go to Seattle, and AWS was not a thing at that point.
They were a thing. Google Cloud is, I can't, they've been around forever. AWS has been around forever.
Yeah, just a little backstory on the AWS thing. There was an initiative inside Amazon at one point that hey, we're solving a lot of these problems. Everybody stop and create service infrastructure endpoints to do all this shit with it. And so they basically completely dog fooded the notion of having all these different services inside the organization. And then once they did that, then they started selling it as a service. Yeah, I don't know that they ever ran on Google.
Yeah, I don't think they ever ran on Google because they were running, a bookstore initially. Remember? And then like Mark said, hey, let's build a better stack to run our store, and now the thing that was running the store is running the company, right? So that's the big money maker in their stack is this thing that they originally built to help them sell better.
Examples of clouds being on clouds, though, like when Apple's when iCloud launched, they hedged their bets and they put half of it on Azure and half of it on AWS while they were building up their own.
Right, so you'll see, so that's a reasonable thing. People that are doing platform as a service, a software as a service, will run on those other clouds, right? Because again, you have an idea tonight to do some software as a service thing. Why would you go and dig a hole in the ground to build a data center, right? When you could literally whip out your credit card and fire up 10 machines in like a minute, right? So that's what people will do. And I think I have some comments on that later about making changes. All right, so the 2006. I remember the old days when we used to go to the pub and there was no Wikipedia. And we would sit there and speculate for hours. And now people are like, no, dude, you're wrong. This is the answer. Anyways, so the folks on the right, I call it smaller, restricted, simpler. Again, making generalizations. So DigitalOcean is a big, infrastructure as a service provider. Linode is similar, and then you'll see lots of virtual private server (VPS) providers. The difference between these types of offerings and the stuff on the left is they have bricks, right? So you will have a certain size server that has a certain CPU, RAM, and disk and bandwidth for a price, and that's the atomic unit of in that world. Versus with AWS, Google, Azure, you can pick and choose what you want. You can pick your compute, you can pick your storage, you can pick your RAM, and bandwidth is a la carte, right? You get as much bandwidth or whatever it is you need, right? So for people that are starting out, simpler, again, if you don't mind running your own infrastructure, managing your own OSs and stuff, you can go ahead and go to DigitalOcean, Linode, whatever, get some size server, build your thing. But if you're like, well, I'm cool with the amount of CPU and RAM that it has, but I wish I had some more disk. Too bad, you got to go to the next one up, right? So if you like to be able to tune and do a la carte, you want to have access to all the switches and knobs, you've got to go to the left side versus the right side, okay? And then, now I know DigitalOcean, for example, they have add-on storage and things, some other options, but those are kind of more recent, whereas the folks on the left, that's just kind of part and parcel with what they offer. You'll also see a lot of regional or purpose-built clouds, so, whether that's like a Rackspace or Liquid Web is another one that I've used, where they're smaller providers and maybe they have a different set of services. Like they will give you like an engineer as part of the package, where it's less transactional. So you can get an engineer with the big folks, but you got to pay for that. You got to have a certain size because they're used to running very large volume, a lot of transactions. They're not going to necessarily want to answer a million questions from some guy or gal that's billing $75 a month. They're like, come on, right? They're going to reserve that level of service for someone that's building hundreds of thousands or millions of dollars a month in cloud services. And then you have other kind of weird things that are public clouds. I mentioned Lightsail. Lightsail is actually part of AWS. So AWS is doing their thing. Some weird guys, DigitalOcean, these VPS, they came up and they started getting really big, really big, really big. So what AWS did is they went and they built a service called Lightsail, which is VPS-like. So you have bricks like the VPS providers have, but you're running on top of the AWS mothership. So you can build in bricks and have it be very simple, but you can, open the cover and see all the user serviceable parts inside, right? You can get into the matrix if you so want to do that, right? So you can kind of do that combination of things. And there's also something called VMC or VMware Cloud on AWS. That is a VMware service. So this is, again, enterprises that are used to running VMware, but they're running out of capacity or whatever. So VMware did a deal with AWS where they have these massive compute things, and VMware bills you for it, but you can run as many VMs as you want on this kind of set of hardware. These giant, massive multi-nodes. But again, it's cloud, and like something like Lightsail, it's running in the AWS space. So if you have legacy workloads that are running on VMware, you can get access to things like S3 and all that kind of fun stuff, and use AWS resources from a very high-speed network connection from your VMware stack. Questions? Comments? All right. Okay, so the big problem with the cloud is this concept of monoculture, and you see it crop up from time to time. So there's a guy, Dan Geer, years ago, I think it was like 2004, he was working for a company called At Stake, and he wrote this thing about computing monoculture. It was about Microsoft Stack and viruses. So if everybody's running Windows, and someone makes this really awesome virus or worm, boom, it takes out everything, right? So there's that old joke about if architects built buildings the way programmers write programs, the first woodpecker would have taken out civilization, right? So you should read, he's done a couple papers, he wrote another one, I think in 2014, just about monoculture and understanding that. So he has a biology background, but he's a hardcore computer science person as well. So he kind of makes the parallels between computer science practices and biology, right? So I have a couple of horror stories with links you'll get. This one just happened last week. Someone redirected a chunk of AWS's address space that's used for Route 53 to steal some cryptocurrency, right? So this has happened. I don't know why. It's the 21st century and we're still having BGP hijacking. Like, I don't know. People are putting cars in space and we still have BGP hijacking. I don't understand, right? But, if this happens to you, what are none of these are kind of impossible to figure out, but you can have your DNS in two places, right? So you put some of it in AWS, and I know AWS DNS, Route 53 is pretty massive, but again, I grew up in the old days where you had to think about all this, and even though I know all these things are really well designed and really well built, I still like wearing belts and suspenders and duct tape. I like it. Seatbelt and an airbag. So there's that. The S3, US East 1. Today still, again in the 21st century, people are putting their stuff on AWS and they're in US East 1, and that's it. Don't know why. So I don't remember, this was it 2 years ago, February? They had an issue with S3, again. Still had the 11 nines of durability. See? Took you out. Like, half the internet was down. And people tried to blame it on, people were like, AWS S3, they messed up. Well, they still had all the data, but AWS gave you the tools to CYA. But people, for whatever reason, again, people don't like making backups or whatever it is. US East 1 went down. You could have replicated your data. But you got to replicate your data to other regions. They have all different regions. The regions are completely isolated from each other. They don't have any interdependencies. We have the tools, we can rebuild him. Let's do it, right? Salesforce.com, I call it the Hell Week. This one's a little bit harder to deal with because, again, this is software as a service. So they had one of their pods, they had some kind of database screw up, but essentially they were down for like a week, right? Now, what do people use Salesforce.com for? Oh no, what do they use it for? Sales, like it's their CRM, right? So there had companies that if you were one of the lucky folks that were on that pod, you were just kind of out of business, right? And this goes back to really thinking through disasters and how you recover, right? So you got to have those pens and pads in the cabinet underneath, just in case, so you can still take orders, right, or whatever it is. And there are tools these days for SaaS platforms to back them up, so you can have a copy of the data somewhere else. Recommend doing that. And then, I don't want to leave anybody out. I got to pick on everybody. Azure had a meltdown in Europe. I thought there was another one. This one was the fire systems went off and took things out. I thought I just saw another one where the blast of the gas coming out of the fire suppression systems, it makes a loud kind of sonic boom. It destroyed the hard drives in the servers because it caused them all to like kind of bounce, right? So when you design a stack, take advantage of the multiple regions that the cloud provider has, and if you can, at least put some thought into trying to get across multiple clouds. Again, even if it's just a copy of your data, so that you're not totally kind of up the creek without a paddle or a bucket. More lessons to how to fix things or how to do things the right way. So you guys are all web developers, I think, or a lot of you are. Infrastructure is code. The cloud, public clouds allow you to have your infrastructure checked in to your repo with all your code. So don't do servers as pets, right? So you call it servers as pets versus servers as cattle. So a lot of people will do also immutable infrastructure. You never patch a server. You build it. You need to fix something. You update your infrastructure as code, and you build a new server, and you shoot the old one in the head. It's gone. You don't care, right? And then the whole DevOps mantra along with that. Learn from our history. We have like 60, 70 years of computer science. Learn from it. You have to take backups. You have to think about resilient systems. Like, I see people make these mistakes every day, like the whole US East 1 only thing. It's silly. You are responsible for your data. We talked about this a little bit earlier. You have all these tools at your disposal, things like the AWS shared responsibility model. It says, hey, we're AWS. We do this. This is all your problem still, right? You can't call up AWS and say, hey, I didn't take any backups and the server crashed and took out my database. Give it back. They're not going to help you, right? You're still responsible for your data. It's still your applications. It's still your business. It's your responsibility. Diversity is a good thing. Like I said, spread it across regions, spread it across cloud providers if you can. Teach the youngins. So I think that's what I'm doing now. I'm a grandpa at this point. Teach people how it used to be in the old days when we had to build servers uphill both ways in the snow. Because these, it sounds funny, but these lessons are important to understand how the stuff is composed. I know you don't want to think about it when you're writing your Lambda functions, but there really is a server, right? So, and then finally, remember, there is no cloud. There's only other people's computers. I think that's it.
So with everything going kind of this public cloud model, do you foresee it kind of swinging back at any point? Like, is there going to be some sort of, I know it's going to get like more cheap on the cloud side of things, but do you think that it's possible that there's going to be a swing from someone?
So is there going to be a swing? So one thing that's I constantly see in the computer industry is it goes like this, right? So maybe we won't all go back to building data centers, but like I know that there are some efforts right now to build like nano cloud, or I can't remember the right, like personal clouds or distributed clouds that are closer to people, right? So if you think about it, CDNs are kind of like that, and even things like AWS, right? So we have the Snowball. Originally, it was like a box of storage. So because there's an old saying, the original saying was, "Nothing beats the bandwidth of a 747 full of tapes," right? So it is huge bandwidth, high latency, but huge bandwidth, right? So you have the Snowball to move data in and out of the cloud quickly, quicker than you could do it over the wire. But what AWS has done is they have the Snowball Edge, where it has more compute resources on it. So you can run compute, and you can even cluster a bunch of them together. So you can order these snowballs, but it's still cloudy because you're paying utility, you're paying the meters running, but you can kind of do a bunch of stuff, compute locally. So you'll have, I think, more weird kind of combinations like that, where you'll have maybe a CDN where you push compute out towards the consumers. But
So do you see possibly in the future maybe a standardization for things like serverless functions? So like Lambda has its own thing, Azure has its own thing. They're all serverless functions, but at some point, could those be standardized?
Could they be standardized? Anything's possible. One thing we do have in the computer industry is a lot of standards. So one of my kind of side projects I'm thinking of is building a tool to help people move between clouds easier, like a migrate. So there's companies that make migration tools now, and it's primarily for folks to take legacy apps, legacy servers, and jam them into the cloud. But I'm trying to think a little bit more. A lot of those tools don't deal with the other, weird like Lambda functions and things like that. So there's that. I think as long as for things like the platform as a service, they're sticky. So I don't think there is a business justification to make. There's no incentive for them to make a standard and cooperate. But it could happen. But if anything, there'll be like 4 standards. So, yeah.
I think that plays into the longer culture because you're talking about how if you start all of it starts to go into this one center, would it then make it easier for us to some take it out because they're going to fall in the center, it has to be some kind of.
So the question is like, will going towards a standard, contribute to the problem of monoculture? I don't think so because. Just like the internet is awesome as it is because people sat down and made some standards, so protocol standards. So if there's protocol or encapsulation standards and things, or like JSON and REST and all these cool things, we have all these different stacks, different languages, different types of applications, but we use these kind of standard ways to communicate amongst them. I think we'll be fine. What you want is a technology break or responsibility break, and that kind of takes up monoculture. Yes, there's going to be protocol, gotchas, like the original NFS. Hey, I'm user ID 4. Are you sure? Yeah, I'm sure. Right. So we had to, we had to make modifications to that to add stronger security. There'll be things like that, but I think overall. As long as the implementation or organizational break between the stacks, it kind of cut out on that monoculture problem.
Do you foresee kind of disappearance of infrastructure as a service more toward platform as a service? Or is that still
Will infrastructure as a service go away? Not as long as old people like me are still around. I still have a server in my house. So I calculated it, and I bought a used server, and I know we live in Oregon, so our electricity is a little bit cheaper than Maybe if I still live in the Bay Area, I have a different opinion on it. But I calculated what it would cost me in compute time and just kind of like flexibility. It's cheaper for me to run my server at home. And I don't want to have to remember to shut my stuff off, right? So I like to just I'm working on something, I'm like, oh, I'm done. I want to go drink a beer now. I'll just get up and walk away and not have to remember to shut it down. So I think there's still a place for infrastructure as a service because somebody will want to create something and really get in there and fine tune it. So I think there's always an option for that. Yeah.
So like the whole thing that happened with the cryptocurrency thing about keep going with DNS.
Yep.
So I don't understand how that happens. I don't get it.
Okay, so I will not talk about cryptocurrency because, yeah. Right, so the way the internet works is it's a series of tubes, right? So you have a whole bunch of routers on the internet, and there are these things called autonomous systems. And basically it's just a collection of networks. And what you say is, hey, I'm autonomous system number 4,000, and these are the network numbers that are associated with my autonomous system. And you announce routes. And what you do is you advertise routes, and then what they do is they look at the path to get to your autonomous system, and they'll go through. So if people aren't responsible and check to make sure using some other system that the routes that you're announcing are yours, a hijack is possible, right? So, if I know that you're the path to get to Mark, but, over here they say, oh no, I know how to get to Mark. I'm like, oh, okay, this looks closer, he's closer to me, so I'm gonna go this way, but it's not really Mark on the other end, right? So that's the problem. So that's basically what they did. They just say, hey, I know the way to San Jose, come this way. And it ended up, they got that traffic, and since they were getting the traffic, they had DNS servers set up that would give a different set of IP addresses to reroute them to these rogue servers. But this is why we have to do things like TLS, because if you have all your sites secured, even though you go to the bogus server, you'll get an error because they won't have your private key. So they'll fail that check. And that's why people should not go to a website that looks like Gmail that says Bob's House gmail.com or whatever, right? So it's the same kind of thing. People still have to be careful, but that's how it was done, high level. Any other questions? Yeah.
Do you think there's a potential for a service where specifically targeting big businesses to set up multi-cloud things? Like, is that already a thing?
Everything is a thing. That's what I found. Everything is a thing. Like you're sitting there like, oh, I have a really cool idea. Oh, damn, like 17 people have done it yesterday. So what you see for a lot of the really big enterprises, the big consulting companies do that. So, Accenture or Deloitte or whatever, they will help deal with all the whole, literally the whole stack, right? So they'll help the business strategize and figure out their financials, do all that stuff, all the way down to figure out which servers to move and all that. So what you've, for like really large businesses, so what you'll see is, what I see is a lot of companies that are doing the tools that are going to those global system integrators and saying, hey, we have the bestest, most awesomest Windows machine migrator thing, right? So there's some opportunity there for those types of tools that the GSIs use because again, they're consultants. If they can do it easier, faster, and charge the same price, they make more money. So I see that's where a lot of that stuff is happening.
And as like a future person in IT, is like how much do you think of their learning will be about managing cloudless services or cloud services and
Serverless services or?
Serverless service, or just cloud services.
Cloudless, we gotta write that down, we gotta trademark that. Because that's the legacy.
That's right now.
Right, so I think there's gonna be more serverless services and things like that, but I just want people to kind of understand how it came to be. And again, I know it sounds like really like grandpa. The kids today, they don't know how this stuff works. I'm trying to figure out how not to sound like the guy that, because we go and plug into the electrical outlet, you have to know how the power generation system is and the steam. I don't want to go to that extent, but I think it's important for people to understand, because what I found is that people without that background, they just go, dude, it broke. I don't know. And that's it, and they're kind of stuck. So at a minimum, they should be using all the tools that they have access to. Like I said before, I know I'm beating a dead horse. Deploying something on AWS in one region in 2018 is irresponsible. I know I'm shooting people in the foot. There's a lot of friendly fire in that comment, but truth hurts, man. Truth hurts. So you're lazy until, it's always better to plan for disaster before the disaster happens. So I'll tell my last grandpa story. So I worked for this ISP on September 11th, and I was actually supposed to be in New York City in Lower Manhattan, but I had spent like 3 weeks in New York, and I was like, I don't want to go back to New York. I'm originally from New York, but I know that life is better on the West Coast, so I didn't go. Something happened, and there wasn't a disaster recovery plan. So I was like live making one up, right? So we had, I don't know if you ever saw pictures of the Verizon central office that was kind of next to the World Trade Center that had all the phone service. It had like a giant, like an 8-foot hole in the side of it and like filled with water. So all of our circuits were down. It was down. Well, for how long? At least 2 months. Like what? So I was routing traffic in California, doing all the BGP routing tricks and redirecting traffic, but I was a good guy. And I was like, get me more Linux servers! Because to hold people's email, because I wasn't clear when they'd be able to get their stuff again. So yeah, it's always better to figure out a disaster plan before that happens, because when the disaster happens, you'll have to fix that and do all your normal work too. Except that people will be coming down the hall with, torches and pitchforks, and that's never fun. All right, I think one last question I get.
So you're talking about multiple cloud services as one, just to be like a backup for the other or something. But since these cloud services have really like 150 or 200 different products, you might like one of them better the way Azure does it.
Mm-hmm. Right. So yeah, there's probably an opportunity to mix and match the services across clouds. Sometimes it may not make sense. Like if you have a Lambda function that's going to do some processing and then dump the storage in a object storage bucket, it's probably easier just to go to S3 as opposed to writing over the internet for a cost to in the same region, right? So you pick. You can. You can. Lambda will.
Not every service will, but many services will. Lambda is one of them.
There's certain things you can't do, like for example with like elastic block storage, it has to be in the same, if you want to mount a volume, that volume can only be mounted by a server in the same availability zone. So not even the same region, but has to be in the same availability zone and stuff like that. So there's all sorts of little kind of gotchas and things for the different clouds and the different services. But it's possible that you can do things like take a whole stack or a particular application and put that on one cloud, and then put a different application on another cloud, It will be kind of a pain to manage it, no lies. But I think at a minimum, you got to do different regions, because like the S3 thing, I mean, I even got snagged by it because I put all my stuff in US West 2, because it's in Oregon. 7 milliseconds of latency. It's really, yeah, right? So I did that, but because of the way I had put I was using the URLs I was using, I wasn't using the US West 2 specific URLs. I was using the generic one, and the redirector, I think, was in US East 1. So they were like, oh, US East 1's having problems. And I was like, ha ha ha, I don't care. But then I couldn't get to my stuff because I used the wrong URLs, and I had to fix that. But so you just gotta like kind of step through all those things and try to think about being diverse as much as possible. But again, you shouldn't spend an infinite amount of money doing that. So with disaster recovery, you don't want to spend more money than you'll lose in a disaster, right? So like when you go buy a cell phone or something like that, and they're like, do you want to buy the insurance plan? You're like, let's see, let me calculate that. Oh, that'll cost half the price of a phone. No, right? Because if it happens, I'll just buy another phone, right? It's easier, it's cheaper to do that, because if you don't, like, drop your phone in the bar and step on it, it won't be broken, so you won't need a new phone. So the same kind of thing happens. If it's going to be really expensive for you to do a multi-cloud thing, either in the bandwidth costs or just the management overhead, then it's probably not a good idea. But I think at a minimum, you should shove a copy of your data or your code or somewhere else just in case. And on that, go drink beer. Thanks.
Okay, so you're going to be around here for a minute to answer some questions. If anybody else has some more. Like I said, we're looking at what we're going to do next month. So I've already got a couple suggestions, but we'll see about it. Feel free to hang out. We'll all be here hanging out and having a good time talking about cloud stuffs and any other web dev stuff. So thanks for coming, everybody. See you next time.